How's it going, guys? Okay, let's talk about domain and range because I want you guys to start getting ready for Algebra 2 because, I mean, essentially that's where you're going next in your math career. So let's talk about something from Algebra 2. It's called domain and range. It has to do with functions, and it's one of the very first things you're going to touch on when you start Algebra 2, so I figure it's a good place to end the year on. So that way you'll be a little bit ahead once you get into Algebra 2. Let's talk about domain and range. On a graph, you can have functions that look like this. Essentially, this graph isn't one that you've seen before, probably. We're used to like straight lines or like parabolas or things like that. But just know that this is the kind of thing we're going to be analyzing. And we're going to talk about something called domain and range. And what domain and range is essentially the domain tells you where all the x values live, and the range tells you where all the y values live on the graph. Now, what do I mean by that? Well, essentially, if we can look over at, I think I have something prepared somewhere. There we go. On Desmos, if we look at Desmos, you can see that I have a pretty similar graph graphed out here. And I have two endpoints. Those are pretty important, so we'll keep those in mind. For this particular graph, if we look at where the x values live, remember x is horizontal, so like left to right. The x values actually live in this range right here, and what I just did was I typed this in from -3 to 1, and you might notice where I got these numbers from. If you look at the x values of these coordinates, -3 and 1, that is exactly where the values of that function live, the x values at least. For range, it's the same thing, except here I'm looking at the two y values, -8 and 4. If I show that, I can see both the domain and range at the same time. And you can see why domain and range is actually used. It's kind of like a boundary, a left and right boundary and a bottom and top boundary for that graph. And it basically makes a rectangle around the entire thing saying, okay, how far to the left does it go, how far up does it go, and so on. Let's look at some DeltaMath problems that you'll be seeing, and then I'll go through some of them with you. These will be on your DeltaMath assignment, so pay attention. You'll get some free answers. Let's get started. Whenever you do one of these problems, first thing you want to ask is, what does it want from me? In this case, it wants the domain. Domain are the x values, and since we're talking about x, you should be thinking left and right. Okay, so you're looking for the leftmost point and the rightmost point. And if we look at this graph, we can see that this point is as far left as it goes, and this other point is as far right as it goes. And you'll notice that these are closed circles. And that will become important later. They're closed dots. You can call them dots, I guess. And the fact that they're closed is pretty important. Either way, we have a left bound and a right bound. And if you want to write out the domain, you have to figure out, okay, where does it go from? What I usually do is I go to the x-axis, because this is domain for x values, and I look at, okay, what if I could draw a box that completely closes the graph in from left to right? Now, I'm not going to worry about closing the box up and down yet because that's range, but if I draw these two lines, you can see that it goes from the point 3 all the way to the point 11. So if I want to write this down, how do I answer this in DeltaMath? I have to be able to answer this. I have to somehow type in my answer here. For the answer itself, okay, since you have domain, you need to use x values. So I'm going to write x here. And I know that x is in between 3 and 11. Okay, so the way to write that in math is to say that x is in between, so you draw your little alligators, right? This is an compound inequality. X is in between 3 and 11. Now, you might notice that I could use less than or greater than in the keyboard down here, but in fact, since we have closed circles, we have to use less than or equal to. Okay, so the buttons you would use to type in this answer are less than or equal to, and that's really the only button you need. You can type in X, 3, and 11 just normally with your keyboard, or you can also click up here if you want to find a full math keyboard that you can use to enter your answer. So essentially, that's the answer. And let's take away 1 point that we got from this. And if you're taking notes, which I highly recommend, this would be the point where you would say, okay, I'll write this down because this is pretty important. Let's see. Closed dots, you need to use less than or equal to. Okay, we're going to come up in a second for open dots, and we're going to talk about what you use for that here in a second once we get to the next example. Let's move on to that example actually. Okay. Let's see, example number 2. Once again, domain. That's going to be x values. That means we need to talk about left and right. And let's take a look here. Now, first of all, I do have a closed dot right here. Closed at that x value. That x value is -8. So it's closed at -8. And it's open over here at 3. Remember, we're still talking about x values. We're still talking about where does it go from left to right. So it goes from -8 to 3. So I can already start writing my answer. I know it's domain, so it's going to have an x in the middle. And I'm going to put -8 on the left and 3 on the right. This will be my final answer. And here's how you determine what goes into these different spaces. We already said that for closed dots, we have to use less than or equal to. And since that's at -8, that's where we'll put that, less than or equal to -8. Okay, for open dots, we have to use a less than sign. Okay, so for closed, you use this symbol. For open, you use this symbol. So we'll put that here. I'll even put open and closed. Open and closed. Okay, so getting the numbers is pretty easy. The only thing that can trip you up are those symbols in between. And you're going to see that for range is pretty similar. Let's do one more domain, and then we'll move on. Let's go ahead and add to this. Closed dots, less than or equal to. Open dots, less than. Just less than, no equal to. I'll kind of bolden that so that way you can see the real difference here. Okay, so those are the rules. That's basically what you need to know. Let's do problem number 3. You can see that we have both open. It's domain, so we need to use an X. Let's just keep everything up. Left, right. And when I start to build my answer, I already know that because it's domain, it's going to be an X. Okay, since they're both open, we need to use just the less than symbol, not less than or equal to, so I can put 2 of those right here and here. All my answers are going to look very similar. And now we just have to find out, okay, well, what is the actual range? How far left and right does it go? Let's see. It goes from here, from -9, all the way over here to 6. And if you want to expand this box so that way you can see it a little bit more clearly, you're more than welcome to do so. You can see that it lives in between these two values, -9 and 6, from left to right. So those are just the numbers that we plug in, -9 and 6. So the final answer would be -9 less than x less than 6. Okay, so really the only math button that you'll need here is less than when you type in this answer. Let's talk about range. Now you might already have some ideas about range. It's very, very similar. Instead of left and right, for range, we're going to be talking about top and bottom. Okay, so let's look at this range problem. I'll go ahead and highlight it. Range is all the y values. So you should be thinking top and bottom. Up and down. It's the vertical axis. So instead of drawing my highlighter thing from left to right, I'm going to go to the most bottom point on the graph. I'll take that end point and this one here that looks like they're in the same place. Okay, and I see where that goes up and down. So it goes from here to here. Essentially we could draw a line. It goes from all the way from -8 down here all the way up to 0. Okay, and for x, if negative 8 was on the left, if negative 8 was on the left, we would put that first. In this case, since we're talking about domain, we're going to put the bottom first. So it's going to be negative 8. And we're going to put 0 on the right. I'm building up my answer once again. I know that this is the bottom and that's the top. Okay, so now we have to figure out what symbols we use. It's the same rules as before. Since these are both closed, we're going to use less than or equal to for my symbols for both of them because they're both closed. Okay, now the biggest mistake you can make is typing in x here. Since we're talking about range, you have to put a y in your final answer. So this is how you do range. Think top and bottom for range, think left and right for domain. Let's do another one. Okay, another range problem. We have range here. I know that means y values. We need to be thinking top and bottom. Okay, and this one is a little bit easier, but what you have to notice is a few things. Let's go ahead and get the bottommost point. It's over here at negative 11. You can just trace that over to negative 11. And that point is closed. Okay. If we take the topmost point, it goes all the way up to positive 11. And this dot is open. Okay, so I'm thinking top and bottom here. So it goes from negative 11 to positive 11. And my final answer, that's the bottom and the top. Okay. Since the one on the bottom, this negative 11 is closed, we have to use a less than or equal to. Okay, and since the positive 11 is open, we can only use a less than, not a less than or equal to, so just a less than. And since we're talking about range, we have to type y in the middle of that. So it's really that simple. Sometimes they'll get to trick you. We'll see if they can trick us in the next example. I believe this one's a little bit more tricky. But once again, emphasizing if it's closed, you have to put less than or equal to. If it's open, you have to put less than. Okay. Here we go. Here's one that's trying to trick you. Now, here's the easiest mistake that you can make. You might be thinking, oh, we're always going to look at the two end points. And if we look at the top and bottom, it goes from negative 9 up to negative 4. The problem is, yes, those are the endpoints of the graph, but that is not how tall the graph is. The graph gets much higher than that, all the way up to positive 5. Okay, so we can't use negative 4. We have to use the very top and the very bottom. In fact, sometimes when you're doing domain and range at the same time, it's actually pretty useful to draw a little rectangle around the entire graph to see where all the boundaries are. And as you can see, it goes from negative 9 to positive 5. That's the top. That's the bottom and the top of this graph. Okay. So one other thing, if there's no dot at all, assume that this is a closed dot. So this is closed up here. Okay, and this one down here is open. So we have a range problem where we have an opened bottom, how would I say it? Limit. The limit as you go down is negative 9, and that's an open dot. So we have to put negative 9 less than, not less than or equal to. This is range, so it has to be a y value. And up here we have a closed dot at positive 5. So we have to put a less than or equal to at 5. And that would be your answer here. Okay, really the only thing that can trip you up is misidentifying something like that. Now, on the DeltaMath assignment itself, I'm allowing multiple attempts, so please do try all the attempts, try to get 100, and try to improve your grade. If you have any grading questions at all, let me know on my Canvas or message me on my email. If you're having any problems with this assignment, I can actually, if you send me a screenshot of it, I can work it out with you and email you back, and we can work together on it. This is assignment number 5. You can find it at deltamath.com along with the last assignment that we did. Any questions, let me know. Have a good day. Go outside for a walk. Do something that you're not used to doing. Mix it up tomorrow. Keep yourself happy and keep yourself entertained. Hopefully I'm helping in that. And check out my other videos too if you want some of that. Have a good day. I'll see you guys later.